Okay, we're going to take a little break from finding new rules for derivatives to actually using some derivatives. So section 3.4, the derivative as a rate of change. Suppose an object is moving according to s equals f of t. The function s equals f of t is called a position function. For some reason, they just like the letter s for position functions. If you don't like the letter s, a lot of times they're not even going to give, you won't see the s, but very commonly there will be an s. I don't know why. T is always going to stand for time. Now some formulas. The displacement of an object over a time interval from t to t plus delta t is given by delta s equals f of t plus delta t minus f of t. Note this is just the ending position minus the beginning position. Generally, in mathematics, the symbol delta means change. That triangle there, delta, Greek letter delta. And so when we say t plus delta t, that's just saying t plus the change in t. And then over here, delta s, that's going to be the change in s, which is what displacement is. Displacement is just how far the object has moved. The change in location of the object is displacement. So delta s is f of t plus delta t minus f of t. And that is just end position minus beginning position. And then I tell you here that the symbol delta usually represents change. The average velocity is given by average velocity equals displacement over travel time, or delta s over delta t, or f of t plus delta t minus f of t all over delta t. So there are the official symbols. I always just remember the words, displacement over travel time, that is what I generally remember. And that's average velocity. That's not velocity at any one given moment, but your average velocity. You know, say you drive home to Atlanta and someone asks you, well, how fast did you go? And you say, oh, well, traffic on average was going 73 miles per hour. That doesn't mean that you were going 73 miles per hour at all times. It's just an on average velocity. Instantaneous velocity, and notice the word instantaneous parenthetically, and we already talked about this once before. The instantaneous velocity is the first derivative. It's the derivative of the position function, first derivative. The velocity is given by the first derivative. Speed. The speed is given by speed equals the absolute value of velocity or the absolute value of the derivative. Speed is the absolute value of velocity. Velocity contains two components, both how fast and direction. Speed is just how fast. So speed is always going to be positive. Velocity can be negative because it contains direction. If it's going down or left, that's considered negative direction, so you'd have a negative velocity. Then acceleration is given by a of t equals v prime of t or f double prime of t, or that is acceleration is the derivative of velocity or the second derivative of the position function. That acceleration is the second derivative. So displacement, ending position minus beginning position, average velocity, displacement over travel time, velocity, first derivative, speed, absolute value of velocity, acceleration, second derivative. So let's use these concepts. A body moves in a coordinate line such that it has a position s equals f of t equal t to the fourth divided by 4 minus t cubed plus t squared on the interval 0 less than or equal to t less than 3, s in meters, t in seconds. Find the body's displacement and average velocity for the given time interval. So displacement. And like I said, I just like the words. End position minus beginning position. So in this case, f of 3 minus f of 0. And so just plugging into the original problem, original formula right there, That's going to be 3 to the 4th over 4 minus 3 cubed plus 3 squared minus parentheses 0 to the 4th over 4 minus 0 cubed plus 0 squared. Now here, if I forgot the parentheses, it wouldn't matter a whole lot because it's 0, but if it was some other number, it would matter. And so what do we got here? 3 to the 4th is 81. 81 fourths minus 27 plus 9. That's 81 fourths plus 18, which is 81 fourths plus 72 fourths, which is 153 fourths. And it said that we were measuring in meters. I don't much care about the units, but if you care about the units, it's meters. But in position minus beginning position. And hopefully I did my arithmetic correctly there. No, I did not. This should be minus right here. Minus, which then is 9 fourths. Okay, so there's my displacement. Then they asked for also average velocity. So average velocity, and I like the words best, displacement over travel time. So we already know that displacement was 9 fourths. My travel time was time 3 to 0 seconds to 3 seconds, so 3 minus 0. So it's 9 fourths over 3, or 9 fourths, showing every step I can think to show. 9 fourths divided by 3, which is 9 fourths times 1/3, which would be 3 fourths. And we were measuring in meters per second, meters in seconds, so that would be meters per second. So there's average. No calculus. All of this was just original function. Displacement, in position minus beginning position, average velocity, displacement over travel time. Okay, next one. Letter B. Find the body's speed and acceleration at each of the endpoints of the interval. So speed is the absolute value of velocity. Handwriting is not good today. Which is the absolute value of the first derivative. Velocity is the first derivative. So we have S equals, and I'm going to get rid of the S because I just don't like S's. So we'll just call it F. So S, which is F of t, which is t to the 4th over 4 minus t cubed plus 2. Make your life easier. That's 1/4 t to the 4th minus t cubed plus t squared, not 2. Over 4, same thing, divided by 4, same thing as multiplying by 1/4. You're not going to need a quotient rule. And so my velocity is given by my derivative. Multiply by the exponent, decrease the exponent by 1. Those 4's cancel. So I get t cubed minus 3t squared plus 2t. So there's my velocity. Then it said at each endpoint. And so my speed at ... t equals 0. It's going to be the speed, which is the absolute value of the velocity at t equals 0. Writing it out in words, because I have a tendency to like words sometimes. And then just plugging into my derivative there, 0 cubed minus 3 times 0 squared plus 2 times 0 would be 0. And my speed at t equal 3 is going to be my absolute value of my velocity at t equal 3, which would be the absolute value of 3 cubed minus 3 times 3 squared plus 2 times 3, which would be 27 minus 27 plus 6, absolute value of 6, which happens to be 6, and I should have a better example where that actually comes out to be negative, but I don't have a better example, so for which I apologize, and that would be meters per second. Here the absolute value doesn't seem to play any role, but speed is the absolute value of velocity. Then the last thing that this one asked us for was acceleration. Well, acceleration is the second derivative. And let's recall, it's still at the top of the screen, that my first derivative was t cubed minus 3t squared plus 2t. So my second derivative, just differentiating again, is going to be 3t squared minus 6t plus 2. And then they said at the endpoints, so the acceleration at t equals 0 is just going to be my second derivative at 0. So 3 times 0 squared minus 6 times 0 plus 2, which would be 2. And if we care about the units, that would be meters per second squared. I'm a math person, I don't care that much about the units. And at t equal 3, again, just plug into my second derivative, so 3 times 3 squared minus 6 times 3 plus 2. So that's 27 minus 18 plus 2, which is 11. And that would be meters per second squared. So nothing too outrageously hard here. Just got to remember the little formulas. Displacement, in position minus beginning position. Velocity, displacement over travel time. Velocity, first derivative. Speed, absolute value of velocity. Acceleration, second derivative. That's the first part of this section. We'll end this first video right here.